Hello, this is Domenico with Easynomics, and we have a quick paper 3 practice question looking at total production, marginal production, average production within theory of the firm. This would have been introduced as part of a higher level topic to understand the marginal cost curve, the supply curve. This is part of the playlist for supply and demand, as well as the theory of the firm playlists. And it goes over the total product curve, the marginal product curve, the average product curve, and how that relates to the marginal cost and average total cost curve. Okay, so let's take a look at kind of quantitative practice question so we can eventually understand the supply curve. In the video that will be linked below, we went over how the total product function increases at an increasing rate from point A to B. And then from B to C, it increases at a decreasing rate. At point B is where the law of diminishing marginal returns sets in. The limitations of fixed resources starts to reduce the productive ability as we add more and more variable inputs like labor, going from 3 units of labor to 6 units of labor. So we have an increasing total product function that's starting to slow down. Then at point C, total product is at its highest point, and that works where the marginal product curve hits 0. And then from C to D, we see that's decreasing. So there's a video that explains this in detail, and I'll have the link for that below. The purpose of this video is just to practice calculating marginal product and average product. So here we have a question. It says table 1 shows production of cups of coffee produced per minute in a cafe. Determine the missing production figures and insert your answers in table 1. So all we're required to do is just fill in these blank spaces. We're provided with a column that says quantity of variable inputs. We're adding labor, 1 unit of labor, 2 units of labor, 3 units of labor, and so on. Total product is the total number of cups of coffee that are produced per minute. So we have 3 cups of coffee, then 7 cups, 13, 18, 20, then starts to plateau at 20, and then it decreases to 17. Marginal product, we should know the how it's calculated. It's the change in total product divided by the change in quantity of variable inputs, and the variable input is labor. And the average product is the average amount of coffees produced per person. So total coffees or total product divided by the quantity of variable inputs or labor. That tells us on average how much each worker is able to produce within a minute. So let's go ahead and begin to calculate this. Let's first work on the marginal product column. So we want to think about, actually, I'll ask you to pause the video, kind of fill in the marginal product calculations, and then we'll fill in the average product calculations and then see if your workings correspond to my workings. So please pause the video and try this on your own now. Please pause the video. Okay, so let's go ahead and try to make these calculations. So marginal product is looking at the change in total product. So we're going to make a note here that we're looking at the change from here to here, and also the change from here to here. Okay, so the change in total product, we're basically going to take 7 minus 3. 7 minus 3 is 4. So total product is 4. And we're going to divide that by the change in the variable input, which is 1. So that equals 4. Then we're going to go on and look at the change in the total product from here to here. And the change in the variable input, which again we see as 1. So we go up by 1. Here we're going up by 1. Here we're going up by 4. And then from here we're going up by 6 units. Okay, so here we're going to take 6 divided by 1, and that equals 6. Then we're going to look at the change from 13 to 18 units, and the change from 3 workers to 4 workers. So we'll make a note that we're going up by 1, and then here we're going up 18 minus 13, and that's 5, going up by 5. So here we can take 5 divided by 1 additional worker, and there is 5. Then we can just continue. So we're going to look at the change from here to here, and the change from this worker to that worker. So again, we're adding 1 additional worker, and we're producing 2 additional cups of coffee. So that's going to be 2 divided by 1 additional worker equals 2. The marginal product is 2. And then we just continue. Here we have the change from here to here, and the change from here to here. So we're adding 1 additional worker. Here we see that there is no change in the coffee production. So it's going to be 0 divided by 1, and that's going to equal 0. The change in marginal product is now 0. So we're at our highest point. Then we continue. We're looking at the change from here to here and the change from here to here. The change from 6 to 7, we're just adding another worker. From 20 to 17, we're losing 3 cups of coffee. So it's going to be -3 divided by 1 equals -3. So here we filled out this column, the marginal product curve column. Now let's look at the average product. Average product is total product divided by the quantity of variable input. So total product is 3, divided by the quantity of input is 1, and that is 3. So on average, this person is producing 3 cups of coffee per minute. Here we take the total product of 7, divided by 2 workers now, and we get 3.5. So each worker on average is producing 3.5 cups of coffee per minute. Now we take total product of 13, divided by 3 workers. 13 divided by 3 is 4.3 repeating. So on average, each worker is producing 4.3 cups of coffee. Then we move on. Here we have 18 cups of coffee divided by 4 workers. 18 divided by 4 is 4.5. So on average, each worker is producing 4.5 coffees per minute. Then we get to 20 cups of coffee divided by 5 workers. We get 4. So on average, each person is producing 4 cups of coffee per minute. Then we get to 20 minus 6. 20 divided by 6. That's 3.3 repeating. So each worker on average is producing 3.3 repeating numbers of cups of coffee per minute. And then last, we get 17 divided by 7. And that works out to 2.43 if we round up to the second decimal value. So on average, each person is producing 2.43 cups of coffee. So this is demonstrating our knowledge of the marginal product function and the average product function by filling these comments with the data that we have in regards to the total product and the variable product. Let's see how this aligns with this model. So the total product function we see as we go from 0 to 3 workers, going from 1 worker, the second worker, the third worker, we see that the total product is increasing from 3 to 7 to 13. So it's increasing at an increasing rate due to specialization of labor, workers dividing tasks between them, not getting into each other's way. There's enough resources between them, so we're getting increasing total productivity. And the marginal product curve is rising from point A to E. So we see the marginal product curve increasing, right? Let's look at the data here. It's rising from 4 to 6, all right? It goes up, okay? So at point E, when we went from the second to the third worker, the marginal product curve is going up to its highest point. And we see the total product curve also at its highest point in terms of increasing at an increasing rate. From that point on, the marginal product curve is decreasing. So from 6 to 5 to 2 to 0, MP is decreasing. Marginal productivity, the additional productivity of each worker is now declining when we go from the third to the fourth to the fifth to the sixth worker. So as we're going from the third to the sixth worker, marginal product is going from E to H to this point here. It's going to hit 0. And at that point, the total product curve is at its highest point. So when MP is at 0, we can see that the total product function is getting to its highest point. It's at the height of the parabola. It's at 20 cups of coffee per minute with these workers. Then we see from 6 workers on, the marginal product curve is negative, a negative value. which is going to pull the total product function downward that we see here. It starts to get pulled downward as we get beyond 6 workers. Not enough space, not enough resources, workers are getting in each other's way. They might be causing cups of coffee to fall on the floor as they smash into each other, and so on. So we see that marginal product data is aligning with this model. Let's look at the average product. We want to remember the relationship between the average product and the marginal product is the same relationship between the marginal grade and the average grade. So we can see that from point A to E to H, right? From points A to E to H along the MP curve, we can see that the marginal product curve is greater than the average product curve. So that's going to cause the average product curve to rise. It's going to go up. If you get an A on your next test and your average grade is a C, it's going to pull that C average up. So we can see the average product curve is rising along that point. So the average product curve is rising as we go from points A to H because the marginal product is greater than the average product. So it pulls the average up. So here we can see that the marginal product is greater than the average. So it's going to pull the average upward. And then we get to the second to third worker. We see that the marginal product is greater than the average. So again, it pulls the average upward. Then we see that the marginal product curve is less than, the average product, the marginal product curve of 5 is still greater than the average, so it continues to pull the average up. So the average is getting pulled up from A to H because the marginal product curve is greater than the average. Then we get a marginal product curve of 2, a value of 2, that's going to pull the average down. So it goes down from 4.5 to 4. So right here, we see that the average product curve is at its highest point, which is basically point H. And then since the marginal product curve is now less than, see, the marginal product curve, the value of the data along this curve is lower than the average, so it's going to pull the average down. So we see if the marginal product value is less than the average product, then the average product value will fall, which is occurring from points H to, let's say Hij, I'll label this point K, H to K. So again, marginal product of 2 less than the average, so it pulls the average down. 0 is less than the average, pulls the average down. -3 pulls the average down and onward. Okay, so we should be able to read that data and understand what's happening with that data and how that data aligns with this model. Common question that could be asked is identify where the law of diminishing marginal returns sets in. That's going to occur at point B on the total product function, or easier to find where the marginal product curve is at its highest point. So we look at marginal product and it's at 5. So as we go from the third to the fourth worker, whereas total product increases from 13 to 18, this is where the law of diminishing marginal returns starts to set in. Okay, so I'll try to create a few more examples of this type of calculation so you can practice, and then we'll get to some average total cost and marginal cost calculations as you might find on a paper 3 exam. And that's it. If you have any questions, you can comment those questions below, and don't forget to subscribe and to like. Thank you so much.